From the second your alarm goes off in the morning, your life is being powered and built by stuff that's pulled right out of the ground. Minerals and energy resources are woven into our world in ways you probably never even think about. So let's dive into this hidden world that makes our modern lives even possible.
And we're going to start our journey in a place you might not expect at all: your bathroom. I mean, it's pretty wild to think that something as simple as your morning routine connects you to this massive global industry of extraction and refinement. So what does toothpaste have to do with mining? It sounds like a trick question, right? But the connection is actually super direct, and it shows just how much we rely on minerals, starting with the very first thing a lot of us do every single day.
Okay, let's break this down. Those little abrasive bits that actually do the cleaning on your teeth, things like silica and limestone, yep, they're mined. The fluoride that helps fight cavities, that comes from a mineral called fluorite. And the reason your toothpaste is that bright white color, that's thanks to titanium oxide. And hey, if it sparkles, you can thank tiny flakes of mica for that. Get this, even the plastic tube and your toothbrush are made from petroleum, which is a major energy resource. It's everywhere.
So we know minerals are in our toothpaste, but what exactly is a mineral anyway? Let's zoom out a bit from this one example and get into the basics of how these things go from being part of the Earth's crust to, well, an ingredient in your daily life.
To a geologist, a mineral isn't just some random rock. No, it has to be a naturally occurring substance. And the key part is that it has a unique, ordered internal structure. That specific pattern on the inside is what gives every mineral its own properties. It's what makes talc super soft and a diamond incredibly hard.
And we basically lump them into three main groups. First, you've got your metallic minerals. That includes things with iron, and others without it, like copper and gold. Then you have the non-metallic minerals, like the mica and limestone we just talked about. And finally, you've got the energy minerals: coal, petroleum, natural gas. The stuff that literally powers our entire world.
Now, these minerals don't just appear out of thin air. They're the result of some incredible geological processes that take millions and millions of years. Some are formed when molten rock cools way deep underground. Others are created when layers of sediment get pressed together for eons. Some are just what's left over after surface rocks break down, and others, like gold, get washed down into riverbeds just waiting for us to find them.
All right, now that we have a feel for what minerals are, let's talk about the sheer scale of getting them out of the ground. If we use India as a case study, you start to see just how gigantic and important these operations are, not just for one country, but for the whole global economy.
Just take a look at this map. India's mineral wealth isn't spread out nice and neat. Nope, it's packed into these specific geological belts. You can see the peninsula is loaded with reserves, but those huge plains up north have almost nothing. This natural lottery basically decides where industries pop up and where economies boom.
And to really wrap your head around that concentration, just look at bauxite. That's the ore that gives us aluminum. A single state, Odisha, produces a jaw-dropping 65% of all of India's output. Think about that. One statistic shows you how incredibly dependent entire regions and even global supply chains are on one very specific place on the map.
But pulling almost 2/3 of a country's aluminum ore from one area doesn't happen without leaving a mark. This incredible scale of extraction comes with some serious consequences, and it's so important that we understand the hidden costs that go way beyond the mine itself.
1%. Just one. Let that sink in for a second. That's the total amount of all the workable mineral deposits in the entire Earth's crust. It's a pretty stark reminder that these resources, which took millions of years to form, are unbelievably rare, they're finite, and we can't make more of them.
And the process of actually getting that 1% is a high-stakes game. For the miners, it means facing the daily risk of toxic dust causing lung diseases or the sudden horror of a collapsing roof or a fire. And for the planet, the impact just radiates outward. Water can get poisoned, landscapes get scarred forever, and the very air that communities breathe gets polluted.
I mean, look at this. The dust that gets kicked up by all this machinery doesn't just settle down nicely. No, it can travel for miles, messing with the air quality and the health of everyone and everything nearby. This is where the kind of abstract idea of pollution becomes very, very real.
So, knowing the incredible scale of our demand and the really steep costs of getting these resources, where do we possibly go from here? This brings us to the choices we all face about our energy future, and it's time to shift from the problems to the potential solutions.
Broadly speaking, our energy options fall into two main camps. On one side, we have the conventional sources, the fossil fuels like coal and oil that we've relied on for centuries. They're finite. And on the other side, we have the non-conventional, renewable sources like solar and wind, which offer a much more sustainable way forward.
And what you're looking at here is that exact choice, laid out as clear as day. On the left, you've got a coal mine. It represents the powerful but limited energy sources of our past. And on the right, a wind farm, a symbol of the potential of clean, renewable energy. The choice we make between these two paths is going to define our world for generations to come.
At the end of the day, our ever-growing appetite for energy, combined with the fact that fossil fuels will eventually run out, means we have to find a sustainable path forward. We just have to. One that balances what we need right now with the long-term health of our planet.
Now, this one idea right here completely flips the script. It suggests that conservation isn't about sacrifice or giving something up. It's actually an active way of producing a resource. Every single kilowatt of power we save is a kilowatt we don't have to go out and mine for, which reduces all those costs we just talked about. So, here we are, at this massive crossroads, between the old ways and the new, between just consuming and actively conserving. What path are we going to choose? The answer to that isn't just going to be shaped by governments and big companies, but by the thousands of little choices each and every one of us makes every day. So the real question is, what will our energy future look like?